Welcome to SCADA, Supervisory Control and Data Acquisition. Today we will talk about SCADA in power systems and have a look at SCADA protocols. Let's start with the energy management system. If you have a power system with all kinds of generation units, substations, topologies and other assets out there, you would like to stay in control. An EMS, an energy management system, provides that. It allows you to operate your system, to react if something happens, even to optimize it by offering a number of functions. State estimation means you get measurements in, but they are maybe incomplete, maybe with errors, and the state estimator calculates the correct system states out of this partially distorted data. You also want to generate forecasts for almost everything, for the weather, for the loads, for the generation units, which is another classical function of the EMS. You want to operate your assets in the most economical way. This leads to economic dispatch and redispatch. The economic impact of power stations depends on energy prices. Or you want to maximize renewable generation, which requires coordination with the other generation units. This coordination is based on the remote control and data, which brings us to SCADA. The technical infrastructure, the IT and OT, that is information technology and operational technology, goes from your operation center over the entire stream of generation, transmission, and distribution down to the customer. All these assets that are in the loop of your power system are accessed with the SCADA system and then provided to the EMS to operate them properly. SCADA means supervisory control and data acquisition, which is the remote control, remote access technology for all your assets in the field. Actually, it's a bit more than this. SCADA has a number of functions. Data acquisition, of course, is one of them. You would like to monitor your assets. You would also like to get an alarm if something is out of bounds. If a temperature exceeds a certain threshold, or if something is broken, or if something doesn't function anymore, you would like to get an alarm. And this is not just a packet that you receive. It's an entire process. The alarm must be confirmed by somebody authorized to confirm alarms. It has to be cleared within a certain time, and if not confirmed or not cleared in the right time, it is escalated to the next level. This entire process is part of disturbance detection and alarm handling. Another function is remote control. Some assets are active. Think of tap-changing transformers or switchgear. You can operate them remotely via SCADA. Data logging sounds trivial, but is of tremendous importance. A real-time database logs all measurements so you can reproduce certain events. What came first? What was the cause of a certain consequence? In the end, you can also generate reports. This can be daily reports to hand over a shift. You can do weekly reports to do some benchmarking later. And there are also fault and incident reports when something happens. All this is part of the SCADA system. The classical user interface of such a SCADA environment is the control room. Here you see a very large one. There can also be smaller ones, even in the substation where you visualize your local assets. In our case here, we have one-line diagrams on the grids. We have weather forecasts, also forecasts of energy markets, and you have things to dispatch visualized on lots of screens. Via SCADA protocols, you can access them. Let's have a look at an example protocol, DNP3. It's popular in Northern America, and it's based on the classical Modbus protocol. Modbus is a general-purpose automation network for programmable logical controllers, PLCs, and goes back to the 70s. DNP3 took Modbus and specialized it for substations. Modbus is a polling protocol, so the receiver must ask for data. DNP3, for instance, added unsolicited messages that do not need to be polled. Another improvement is efficiency. As you can see here, a classical Modbus node can only deliver data if polled, and DNP3, however, can ask if something has changed. And if this is the case, only new data is transmitted. DNP3 is not the only SCADA protocol out there. There are rather traditional or even outdated legacy systems that we often have to deal with. One is the 6870-5 family with -101, -103, and -104 for point-to-point or multi-point connections. DNP3 and Modbus TCP, for instance, packed traditional protocols into TCP/IP frames to transport them over Ethernet, for instance. And 6870-6 is an inter-control center protocol where entire control centers can exchange data. So, if you have such a zoo of different protocols, you might also need protocol translators, gateways. They are usually lossy and subject to latencies, which is not what we want. We want a clean and simple architecture. In the next lecture, you will hear about IEC 61850, which is the current standard to achieve exactly that. Today, we talked about SCADA, which is part of the energy management system. SCADA is a remote control infrastructure with certain protocols that are transporting commands and measurement values from and to the control room, where the EMS functions, such as data logging, economic dispatch, or alarming, are implemented.